Hello, this is Abhishek Vyas. I am presenting the Advanced Computer Architecture Lab project for BTech CSC 8th semester. Um, my instructor is Mr. Deepak Mahavar. This is a project made for the ACA lab, and the title of the project is Reverse Police Notation Calculator in MIPS assembly language. Let's move on to the first slide. So it's the introduction to the reverse police notation calculator in assembly language. So the project is about calculating arithmetic expression using reverse police notation in the postfix form. Basically, reverse police notation calculator calculates based on the postfix form of arithmetic expressions. Reverse police notation calculator is implemented in the MIPS assembly language here using functions and various loop functions and one main function. And this RPN function in MIPS assembly language processes an ASCII string containing an arithmetic expression in postfix form, and the input is also a ASCII character string, that is an arithmetic expression. The arithmetic overflows and underflows are taken care of in this RPN calculator. And now let's move on to the next slide for hardware and software requirements for this project. The hardware and software requirements are MIPS assembly language assembler, which is available free on the net using the freewares of Qt Spin simulator and Mars assembler 4.5. Both are freeware and available on net. The OS is Windows. OS I use is Windows 8.1. You can use any less Windows OS like Windows 7 or any other, it doesn't matter. And now the hardware is for me it was 1 GB RAM minimum. Now it depends because it's not that much of a memory intensive project, so you can use 1 GB RAM or less. And I had a 64-bit OS with the x64 based processor, Intel i7, but doesn't matter, you can have lesser processors. And at least 2 GB SD space I presume, but less is even not that bad. Now let's move on to the code snippet for our project, implemented project. As you can see, this is the text segment for the MIPS code, and in the start one we are just calling the typed expression to print typed expression from the user, and then printing it and putting it into the buffer address and defining the maximum length of that and other calling operations. And then the loop, it loops through and adds adds to the stack. So this is the postfix expression. Arithmetic expression is when the user enters the expression on the console, it is put into a stack. It is, and based on the postfix form, the pops are done, and then the arithmetic expression is evaluated in the postfix form. Stack is the best data structure used for it, and so you can see a lot of stack pointer registers are used here to push and pop the symbols of the arithmetic expression. And as you know, the ASCII character string is the format for the input of the arithmetic expression, so stack is considered to be the best adjusted group of character strings. And this is the data segment. First, it is the user asks for expression that is single digit numbers only. Just to make a point, it accepts single digit numbers only, not double digit, like from 0 to 9 it will accept and process, not more than that, because this is assembly language. As the digit increases we have to increase the code, so I just made it for single digit expressions. Okay, but it will give the answer for every single digit expression, no matter how long it is. And we have already given the max length of word 31, that is, the word is 4 bytes, so 31 into 4 you can see. Buffer space is also 31, and other things we have defined here in the data segment as variables. Now after assembling it and you can say running it, this is one of the outputs of the program. The expression here is 4, 5 star represent multiply, 2, 3 minus and divide. So this expression basically confers normal expression to 4 into 5 to 4 multiplied by 5 divided by 2 minus 3. So that results minus 20, and that is the correct expression for when evaluated normally or in postfix. Correct answer when evaluated normally or in postfix form. So in conclusion, we can say that the implementation of RPN calculator in MIPS assembly language works correctly. The implementation is success. And in the conclusion, I am just giving some other output examples how the postfix evaluation actually works. So you can see if I have inputted other things and what will be the results shown. And it also shows the arithmetic stack underflows and the arithmetic overflows are taken care of basically. And it also shows how when you input in invalid expression, it shows invalid expression. Alright, thank you very much. I hope you enjoyed the presentation. Thanks a lot.